Good afternoon, and welcome to today's webinar, AutoCAD Electrical Point-to-Point Cable Wiring. So we are going to hold all the questions until the end. However, at any point, if you need, you could go ahead and in the question area, you could go ahead and type in your question, and when we get to the PowerPoint slide, we can either unmute lines or just repeat the questions that have been keyed in through the session today. So who is M2 Technologies? We are a manufacturing technology consulting firm that has been in business for 24 years now and has 7 locations throughout the United States and are a close partner with Microdesk. So M2 Technologies basically handles the manufacturing side of the business, and in those projects or consulting engagements where we need some building or civil work, that's when we work with our Microdesk partner. We work in several different areas. BIM for manufacturing, creating content, helping people manage their assets as far as their CAD software. We can help you optimize your processes and workflows. And we can help with data management. So managing your files, check in, check out, ECO and revision processes, as well as all that data that sits behind those processes. We have several leading partners. Number one, we are an Autodesk partner with a gold status. We work with Panzura for any of that data replication that you need between different sites. We create a lot of learning content with our partnership with Pinnacle, or could also be known as Eagle Point, and also Bloombeam. So we provide a lot of different services around those different areas. Anything from helping you manage your CAD software to your design files, as well as your simulation, generative design, visualization, CAM, training, and pretty much anything in between. So we are really here to serve you in your needs as far as manufacturing, architectural, or civil needs. So my name is Tim Shull. I'm a Senior Solutions Engineer with M2 Technologies. I've been here for 15 years, basically providing consulting and support for our Autodesk products, our process optimization, consulting services, as well as data management. So pretty much I've handled it all. Before that, I actually worked in the industry as a mechanical designer for 9 years, but don't let that fool you, because I have been using AutoCAD Electrical for the last 15 years and even helping customers with its use and adopting it and creating multi-user deployments and multi-user environments, as well as even some design support work around AutoCAD Electrical too. So even though my background is mainly around mechanical design, I still have lots of experience in AutoCAD Electrical and its use and implementation. And speaking to that, I have been a certified instructor and even evaluator for Autodesk for a number of years, and I'm certified through Autodesk as an implementation certified expert too. So the agenda today, what we're going to be doing is taking a look at that point-to-point design in AutoCAD Electrical. It's just another design methodology that you can use there. There are several that we're going to go over to start off with. And what I really wanted to do is be able to set somebody up for success. So I wanted to kind of go through the whole process. I'm not going to say the process is super difficult. It's actually pretty easy to do it. But really the first thing that you have to be aware of before you engage in creating those point-to-point documents is really in the component library, okay? So we're going to explore the component libraries and even talk about how to create custom components to some extent. And I'm going to demo some of those pieces for you. And once we get past the component library, we're going to talk about the schematic environment itself, specifically point-to-point design and the tools that you'd use in the software. And then building upon that schematic environment, moving into actual layout itself. So the design methodology. So there's 2 main design methodologies with the electrical design. Okay, so you have your ladder logic. So basically you have your vertical power runs, rungs, and then you have your horizontal rungs where you're doing your control circuit. Okay, so that's the example on the left. Typical ladder logic, very common. I think most companies probably use ladder logic for their design. The other methodology is point-to-point. Now, in point-to-point is more of a physical wiring. So I can consider it, you're going to create that block or whatever you're going to wire in between one another. And it basically goes from one point on one object to the point on the other object. So generally, it's really easy to understand how things are wired together. And they're really good for simple designs, especially when you're using, placed components. Especially in cable design. And that's why I kind of wanted to take that direction with this webinar, because for cable design, it's really good for that when you're just wiring between different connectors and things like that. And, point to point is really straightforward. People, could easily understand how it's connected together. Where the ladder logic, if you're looking at this, you may not know exactly how it's wired together. And there's some tools in there, like the wire sequences, that you really have to go through and manage those wire sequences so you get proper to-from reports out of like a ladder logic document that you don't have to do when you're doing point-to-point wiring. So the component library, it really is one of the most important things on AutoCAD Electrical, and it's that thing that's going to really, strive you towards, excellence in creating your designs. And that's because this library contains over 2,000 symbols out of the box for you. And it's a wide variety of different standards that they conform to. So anything from AS to GB, IEEE, or more commonly in the States, the JIC and the NFPA, maybe IEEEs too. But you can see there's just a ton of standards built into here. Now, the one thing that I think it could use some improvement on are the connectors. Okay, specifically when you're talking about the physical footprint and even the catalog database. It's, even though there's probably hundreds of thousands of components in the catalog database, it's probably not quite in depth as you'd need if your focus is strictly on creating a point-to-point wiring schematic. Okay, so, and that's why I really want to explore that area first. So, creating a custom component. I'm going to take you through some of the steps, not all the steps, but I'll make sure to give you the full picture. Okay. So inside of electrical, there are several different pieces that go together to make a complete component. Okay, so one of the first things is the actual symbol itself. Now the symbol really could be two symbols if you think about it. So you could have a schematic representation of that, and hopefully you just use the connectors that are available from AutoCAD Electrical. You could do that, although you could create custom schematic symbols too. But really, I'm focusing on the footprint side. Okay, so there's tools in the software that help you create intelligent AutoCAD electrical blocks. Okay, so these aren't AutoCAD blocks, even though you're kind of using the same tools to create them. The tools inside of electrical have you add specific attributes that give it more intelligence, and that's really where the heart of the intelligence is coming from in AutoCAD Electrical, are the block attributes themselves. So if you want to apply things like catalog data or pin information, they're captured in the block. And then there is a project database that basically rolls all that information up and allows you to present that into a report or share information across multiple drawing sheets. Okay, so really the heart of it is the block itself. Okay, and this is an example of an AutoCAD electrical block and some of the attributes that you may want to apply to those blocks. Now, in addition to the blocks themselves, there's also a catalog database, which has the catalog information that you're going to apply to that component. And then you also have a footprint lookup database. And basically what that does is tie the manufacturer catalog number to a specific block itself. Okay, so it allows the software to be able to find it and place it. Okay, so you can see there's symbols creation, there's a catalog database, there's a footprint lookup database. So there's 3 different pieces that generally have to be touched, and probably even 4 pieces if you want to have it in the icon menu so you can place it easier. So like 3 or 4 different pieces that are involved in the process of creating a custom component. Okay, so let's go ahead and take a look at the first piece. So I'm inside of AutoCAD Electrical now, and I have some components that have already been created as AutoCAD Electrical blocks. So that process is really done for us already. But what I want to do is just maybe explode one of these so you can see it. I'll just select that component, can explode it, and there you go. You can see it's the same type of information we just saw in the PowerPoint a moment before. So all these attributes that are associated to this block, super important. It's very important you follow the process to build the symbols properly. And this is something that we cover in our training. And the tool that you'd use to create that is called the Symbols Builder. The Symbols Builder, it's located on, well, several different tabs here. On the Schematic tab, we have a Symbols Builder. On the Panel tab, we have a Symbols Builder. And basically what it does is it's like an authoring tool using the block environment inside of AutoCAD Electrical, very similar to AutoCAD, and basically just has a palette that tells you what attributes should be added, and it makes it very easy to add those attributes to the component. Okay, so I'm not going to go through that whole process, but just know it's called the Symbols Builder, and that's what you use to apply the block properties to specific geometry so you can build in the intelligence that you want into that symbol itself. Okay, and like I said, we do cover that in our training if you wanted to take the next step. So with that part being done already, some of the other areas that have to be explored are maybe the footprint lookup database. Okay, and you'll notice here in the electrical, we have several different tabs, a schematic tab and a panel tab, and a footprint is generally associated with the panel environment. Okay, so this is where you're going to find the tool to basically link up the catalog database to the actual component itself, the physical representation of that block. So it's a little bit hidden here under the other tools. And when I open this up, there's a couple different options. We could edit an existing table, or we could create a new table. So in this case, I'm actually going to create a new table. I'm going to call that AMP for the type of symbols I'm creating. And we have this blank environment right now because I haven't created any of these components before. I'd say add new, and this is where I'm going to put in things like the catalog information. So if I know this AMP part number starts with like a 205 841-1, and I'm going to put an asterisk in here too. And basically, when you have components, and I'm going to use like a pilot light as an example. So when you have a pilot light, maybe you got a green one, a red one, a blue one, an orange one, a white one. You know, they could be all sorts of different colors, but really the physical representation might be exactly the same for all those components. So the catalog number could be a variety of catalog numbers. And basically by putting that asterisk in there, in this case, it's a wildcard. So it allows it to say anything that starts with these numbers specifically. However, after 1, it could be any number. It doesn't matter. And that would be, you know, a wide variety of different, maybe connectors in this case, or pilot lights as my example. Okay. The next thing I'm going to do is tell it what block should be used when I use that catalog number with the wildcards. So I'd browse out, and inside of AutoCAD Electrical, when you install it, there's all these symbols, 2,000 or more symbols. And I actually created a new folder here where I saved my previously created symbols. Okay. And I'm going to go ahead and select the symbol that I'd like to use for this footprint. So there we go. So anytime I use this catalog number, it's going to pull this footprint. Simply click OK, and now I've got a new one in there. And of course, I could add another record here. So maybe in this case, we've got a 747-904-2. And again, I'm going to browse out, identify the block that I want to use with it, and click OK. And basically, that's what goes into setting up a relationship between the catalog database and the physical footprint representation of the symbol. And the reason I wanted to make sure I showed this is because I believe this is one of the areas that could use some expansion in the standard catalog database. So you'll find that when you're doing point-to-point with connectors, especially something that you'd use on a cable, it's more likely that you're going to have to go through and create these custom symbols. Okay, so I wanted to make sure to show that. Now, the next step in this process might involve actually placing these into an area of easy access. So if I'm going to use this connector a lot and I want to access it quickly, and when you're using AutoCAD Electrical, if you're not familiar with it, one of the most common ways to place a component is through the icon menu. So when I click on this, it's going to open up the icon menu, and this one's specific to the footprint environment. You'll notice all the different types of components in here, and none of these really say connectors. Okay, so maybe what I want to do is create my own custom icon menu, submenu, and include the connectors that I just created, so they're easily placed into a design. Okay, and we do this through the icon menu wizard. And there's several different icon menus to choose from. There's a schematic, there's a panel, there's actually a pneumatic and hydraulic and P&ID ones as well. You can even create your own custom ones if you want. In this case, I'm going to modify the standard one that's available out of the box. I'm going to go ahead and select OK here. You can see basically the interface looks exactly the same. The only real difference here is you have this additional button in the upper right hand corner that says Add. And if I go in here, I can add several different things. I'm going to start off with a new sub menu, and I'm going to call this just connectors. So connectors. Then I need an image. I could use the active window if I want to, so it's going to grab a screen capture of the active window. A lot of times you'll find that you want to kind of modify and create the file ahead of time, so you get a nice, pretty image that stands out. You can see a lot of the images in the icon menu that are probably created in like Microsoft Paint or something like that. This is simply just a screen capture in this case. I'm going to select OK, and you can see it doesn't stand out quite as nice. And then I'll dig into this submenu. I'm going to select component, and this is how I could go through and add specific components now. So I'm going to call this connector-01. For the image file, I'm going to browse out. Let's say we want to use this one. So I've already pre-created that one. I was kind of zoomed in a little bit more. And then I need to tell it what block is associated with it. So I'd navigate out. And again, these are just going to my AMP folder that I've created in my catalog location already. Going to select OK. Going to click OK. And basically now I have that new connector in there. And then I could, of course, I could continue on if I wanted to create another one here. Maybe this would be connector 02. Again, I'll browse out. I'll just grab a screen capture that I created for it. Going to browse out and grab the appropriate block for that. And now you can see I've added those in there. And that message was basically saying I just had done those ones before. So it remembers when I was preparing for this that I had already done that. So that's nothing to worry about. But basically, you can see it's a pretty simple process. And when I click OK here, when I'm creating a panel or a cable in this case, I could go to the icon menu. And now I could go in and select from these different connectors. Now in this case, I only put one view in there. I could have certainly included multiple views for the same connector in there. So if I needed a front and right side or left side or top view or whatever it happened to be, you can incorporate those all into the same symbol and just maintain the view that you want to keep, or even keep both views. That'd be okay too. So it all depends on what you're trying to achieve when you create these different schematic symbols and panel symbols and footprint layouts. So I think you can see the process isn't really difficult. It does have several different pieces that are going to work together to create your final component. But you know, once you get the process down, it's pretty straightforward. And most of the time, you can actually grab all the geometry from the manufacturer. So like you could go to the AMP site and usually just download these. The only thing you have to do afterwards is make sure you take it through the wizard, so the symbols wizard or icon, so you can build those out and actually add all the attributes that you want to it. Okay, the symbols builder. So let's go ahead and move on to the next thing. So once you've authored some of the components that you have, now it's time to maybe start the design. Now, I'm going to assume that we're going to start the design in the schematic environment. The schematic environment would involve that point-to-point connection. And the point-to-point connection, you're going to make that using what are called wires. Okay, so if you're using AutoCAD today, if you're drawing a line isn't a wire, technically, I guess. But a wire essentially is it's a layer but it has a certain naming convention that the software recognizes, okay? And that naming convention is what really gives it its intelligence. So what color it is, what gauge it is. And you can include a variety of different user parameters or properties into that naming convention too if you want to, okay? So it could be a really simple naming convention or complex, but generally at the root of it, it's a color, it's a gauge, and then it is applied to a specific wire layer, okay? And that's how the software knows that it's a wire, because it exists on that wire layer. Now you could insert wires individually, one at a time, or you could actually use some multiple wire bus commands, giving you the ability to insert multiple wires at a time. Now, once you have all those wires into your design, one of the other things you might want to do, especially in our case, is apply something like a cable marker, okay, or a cable with shields. And what this is just like any other symbol. So just like we created that symbol a moment ago, this cable marker is also a symbol that can have catalog data behind it. And this catalog data gives it that intelligence, so it knows, in this case, what cable it is, okay? And of course, we could have these markers, have children components too. So that's basically building a relationship between essentially wires almost. So you drop in a parent marker that has the catalog data. Then every conductor gets a second marker, which is considered a child. And that makes sure you could build references in between the parent and child, because you're not going to have the cable catalog number called out for each conductor, because then you'd end up with 5 of the same cable, right? You don't want 5 parents in there. You want one parent with the catalog information. Then all these conductors are children, which just inherit that same catalog information. So basically it's one catalog number opposed to like 5 catalog numbers, because you want your bill of materials to show properly as well. Now, once you get your wires in there, you're probably going to want to number those wires. Okay, so this is one of the big advantages of AutoCAD Electrical too, is you can use the automatic wiring tools. And these wiring tools, the numbering specifically, has properties associated with it. So you could create what are called project definitions or project properties for how you would like to number things. And because in this case we're using a point-to-point wiring scheme, you'd typically use a sequential wire numbering scheme for those. So it just starts at, say, 1 and goes to 100, all in order. There's a number of different ones that are available from the system. So you could also do PLC I/O addressing. So if you have some PLCs in there, I'll have the address as the wire number. And in other cases, say if you did have that ladder logic, that's when you generally use like a reference line number, okay? And you could apply those really quickly. Now the next thing is the connectors. Now you don't have to create custom connectors in the system, okay? So if you wanted that connector to look a certain way, I don't know that that would be necessary, because there's actually a connector tool that's built into the software that makes adding connectors very easy and very generic, okay, as far as the schematic size. Now on the footprint side, it's a different story. You want to create your custom footprints for those. But generally, out of the box, this connector command works just fine for the connectors you want to create. You know, it really doesn't matter what they look like in the schematic, as long as they have pinpoints and maybe definitions for the pin locations and things like that. Doesn't really matter what they look like, okay? Now, in this case, we're mostly focusing on connectors, but I will state, you know, if you had like a custom power supply, something like that, that had pin locations on it, you would probably want to create that as a schematic component and document all the pins and pin connection points on there for something like that, okay? But in our case, since we're mostly focusing on like a cable design, the connectors are what we really care about, and how we're going to apply the different wires and multi-wire OS and things like that, so we could get to the final cable result in the layout. Also, the connectors, since they are so flexible, offer a variety of editing tools. So once you place a connector in there, you can rotate it, you could stretch it, you could add additional pins, you can subtract pins, you could even move pins and swap pins around. You get a lot of control over it. You know, if you create that, say, power supply that's got those pinpoints, it's not going to have that type of flexibility, okay? Or even if you created your own custom connector, it's pretty much going to be static, whatever you draw it, where this connector tool gives you, like I said, great flexibility and how you can add and work with those connectors. So I highly encourage people to use these connectors as much as you can. Don't create any extra work for yourself. Okay, so let's go ahead and take a look at that. So we're going to move off of this drawing sheet. Okay, so here we are in the schematic. And in this particular case, what we're going to do is finish up this cooling fan circuit, basically. Okay, so you can see down here we have a fan control PC assembly. And even though this is probably a purchase component, and it's a connector was just inserted on top of it, so you could still take advantage of all those connector tools. So it really depends on how you want to leverage the tools. You know, the connectors make it really easy. We have some overhead panel here. We've got a circuit breaker. We've got some lighting distribution panel. We've just got all these different areas. But really what it comes down to is we just want to finish this circuit, and our main focus is going to be on that fan temperature control. So the fan's going to kick on and if it gets too hot. Okay. So the first thing that I'm going to focus on here is the connector itself. Now the connector is actually found on the schematic tab. Okay, so this is a schematic tool, and it's on the insert components panel. Okay, so I'm going to go ahead and select this, and there's a variety of different options in this dialog box. Okay, so the first thing that we're going to do is really define what we want this connector to be. So what's our pin spacing? So in this case, 3/4 inch. That sounds pretty good. For the circuit breaker, we only need 2 pins, so I'm going to key in 2 pins. I'm also going to set this to be a fixed spacing. Okay, so regardless of where I place this into the design, it's always going to be 3/4 inch spacing between those pins. I'm also going to create a pin list. So I want the pins to be 1, 5. And the reason I want to do 1, 5 is because this connector is going to have a parent-child relationship, just like I spoke to about that cable. And it's nice to be able to do this because you could literally place the pins to a connector in multiple different locations in the context of your project. You know, in the same drawing, or even maybe a different drawing. Doesn't really matter. Okay, and to turn on that child-parent relationship, right here, start connector is pin. So this, or child, excuse me. So this is going to be a child connector. Okay, which means I am going to have to build a relationship with this connector to the parent, where it's going to get all of its information from. Okay, now also in here, I'm going to expand the details area a little bit, and I do want to place in both the plug and receptacle. You'll notice different options in here. You can do the plug side or receptacle side only. You can also control like the pin locations. You know, you want those on the plug side or receptacle side. Lots of different options in here. You can even control the size of the connector itself if you wanted to adjust the geometric values. There's controls in here for the positioning of it, flipping it, okay, and so on. I'm going to leave it in that orientation right there. I think I've got everything I need. So 1 and 5, 2 pins, all child. Yep, looks good. I'm going to go ahead and insert this. And basically when I insert this, it is going to be attached to my cursor. And you'll notice there the arrow. So the arrow is basically showing me what side it is. Okay, is it the receptacle or the plug side? And in this case, I could tell the arrow is pointing the wrong direction. So even if you didn't have the direction set properly, you can use different tools on your keyboard to flip that. So like tab will flip it, or you can type H or V if you want horizontal or vertical. And then once you get it into the proper orientation, I'm just going to go ahead and go over and make sure this is connected right to my circuit breaker. Because remember, my circuit breaker in this case is just this kind of generic reference. I really care about just that connector that's going to attach to it. Now, in this case, I have the child component insert and edit dialog box. And this is where you could build in that parent-sibling relationship. And that sibling relationship can either be in the same drawing, across project drawings, or I can pick it from the existing drawing. So in this case, I know that I want this connector to be basically the same as this connector. So it's going to be a PJ8. And you'll see in here it's automatically going to consume that kit tag, make it part of this component because it's a child. It's the same component, one catalog number, spread across this drawing in multiple locations, or like I said, between drawing sheets too. So that looks pretty good. I'm going to go ahead and select OK. I've built in that relationship. I can see here that, well, that tag didn't really end up in a great location. And keep in mind, these are AutoCAD blocks, so it's going to have the default attribute location. But AutoCAD Electrical does offer you a number of tools here for working with those attributes after it's been placed. In this case, I just want to do a simple move operation, but you can do a number of different operations with your attributed text after the fact. And the cool thing is, it's only going to affect the one block that you have inserted there. So if there's any other blocks that are essentially the same, it has no effect on those or their attribute placement, okay? So it only affects the one that I'm touching. All right, so let's start a little wiring here. And the thing is, remember, wires and lines aren't the same thing, okay? If you worked with AutoCAD for years, you've been drawing lines, and very familiar with probably that rubber band line that it creates at any angle, and basically you're creating one line at a time, okay? And one of the first things that generally has to be done is the creation of wires. Now, when I talk to customers, when I'm consulting with them and building out the wire types, is usually we'll define a list that they want. And then as part of the template, we'll actually build these into the template. So for example, if I wanted another brown wire type here, so I type in brown and I could hit tab, and you'll notice here, this is the layer name. It's going to fill that in. And then I'm going to go with the gauge, so maybe 18 AWJ. So we've got two brown wires in this file and multiple other wire colors as well. And what I can do here is also adjust like the layer properties. So things like the color, like I know this is a brown wire. Maybe I'll select the brown color for that. I could also do different line types. I've run across a number of customers that have used like hidden lines for field wiring and things like that. And you could certainly adjust this as needed for your needs. And once I have the wire configuration set in here, I'll just click OK. And now I'm ready to place a wire. So I'm going to place a single wire using the wire command. And what I want to do is make sure I'm using the right wire. Of course, you'll use one as the default, the one you use most frequently. But if I type in T, enter, this allows me to change the wire type as I'm placing a wire. So it's really handy. I could just come in here, say, okay, I want to use that brown 18 gauge wire that I just created. I'm going to select OK. And now I'm creating this wire. And I'm just going to simply click over here. It's going to grab the connection point to the connector, and then I can drag this out. So look at how it's creating this wire. So it's two line segments at a time at a minimum. Okay, so it's not like a line command where you're just doing point to point. And even beyond that, if I come down here and say I want to connect to this other connector, it has some avoidance technology built in. So it understands that, okay, well, this connection should go straight into that connector. So it's going to add an additional wire segment and also try to avoid anything that's in the way. Now, does it avoid everything all the time? Well, not really, but it does help you in many cases to make it easier to insert your wires because it's using that technology to avoid other wires and connectors. Okay, sometimes things can't be avoided. All right, so you can see there, very quick and easy. I was able to go in and create a new wire type and insert that. Looks good, but there's still a couple more connectors that I need to create. Okay, so I'm going to slide over a little bit. You can see we have our lighting distribution panel, and we want to place another connector in here. So I'm going to go back to my connector command, and in this case it's not a child component, and it's going to have four. You can see there's four wires out there that I want to connect it to. The pin list is a little bit different. It's going to be A, B, so it's going to be alpha pin list, so A and B. And one of the most important things here is the at wire crossing option. Okay, so what that's going to allow the connector to do is be more flexible. Okay, so if you've already got the wires in there, and maybe they're even at different spacings, like this example here, you can see we've got the red wire up there, and then these three blue ones down there. You know, it can accommodate for that. And also in this case, I'm just going to place the plug side. Okay, so I'm going to go ahead and insert this. And you'll notice I've got it attached to my cursor again. And if I go up to this wire at the very top, it's going to highlight. And it's a little hard to see there. There's a little graphical change that you see in the connector. But if I click, what you'll notice is it's going to put all those pins wherever it crosses a wire. Okay, which is really handy. You know, if you've got a ton of wires in there already, you kind of have the design in there the way you want the connector to conform to whatever is already existing. All right, so really flexible and easy to place in there. And there it is. And you know what? Let me go ahead and just change this connector tag. So this is going to be a PJ15. All right, let's click OK. There we are. So we got that connector in there. And if I pan down a little bit, let's take a look at our fan control. And if I right click, edit components, this is how you get into the edit insert component dialog box. And this dialog box here is the parent version. Okay, so you noticed before we saw the child version first, they look a little bit different. And that's because the parent is where all this really good important information is being added. Okay, and in here we also have things like pins. So each one of these pins can have its own description, and in this case you can see it says on. We actually want to change that to off. And click OK. And now it says off in this location opposed to on. So you can have all these descriptions show next to your connector so you can exactly see how things are being connected and used together. Okay. So everything's looking pretty good here, but maybe we realized that we need two wires that have 28 volts, okay? And right now we only have one, so we've got this one 28 volt lead, it's on pin 4, and we want that 28 volt to be connected to the same connector in a different pin location because of how we're going to wire this thing. And right now that's a little bit of a problem. So the first thing is, okay, well, we're going to splice into this wire, okay, and then we're going to make a connection back into that same connector. So there actually is a insert splice command, and that takes you into that icon menu we talked about before when we created those custom footprints. And the splice is just like any other catalog component, and I could select that, and we're going to go ahead and place that right onto our 28 volts. In here, we could apply catalog information and descriptions. In this case, we're going to keep it pretty straightforward. We're just going to drop it straight in there. But I still have the problem of this connector doesn't have 6 pins. Okay, and if you're using standard AutoCAD, maybe you'd have to delete that connector out and insert a different connector or go through some other editing tools and stuff like that. But keep in mind, this is an intelligent symbol that's already inserted into the design. And what I want to do is go ahead and just update that. And there are a lot of different editing tools that we have available to us for these connectors. One of these is the stretch. So I can simply use the stretch command, pick on that connector, and just drag this out to a new desired length. That was quick and easy. And then the next thing is, well, you know what? I need to add another pin. So you can see in here, one of the options is to add a new connector pin, but I could also remove and swap and do other things to pins as well. In this case, that's the connector, and I'm going to go ahead and drop this pin in now, right about there. So wherever you click, it's going to drop that new pin into that location. And of course, now I want to make sure I can wire this up. So I'm going to go back to the wire command. And before I place a wire, of course, I'm going to go check my wire type. In this case, I want to use a blue wire. And then I'm going to connect that to my splice. And you can see here, the software is smart enough to know that, well, I'm not going to come straight into this component, the splice component, with a straight line because there's already a wire connected to it. So it's going to avoid that overlap of those two wires and automatically put in a 45-degree wire. There's also other options for like a 33-degree and a 67-degree that are built into the software too. And wherever I put that pin, you'll notice I can get that to flip around and connect to that pinpoint really easily. Now, of course, I want to continue that over to the next connector. So I'm going to type in T, enter again, and just change this to a black wire now. Going to connect to pin 6. That's going to go down here to pin 41. All right, looking good so far. Now, the next thing is I do need to connect all these pins of PJ6 up here to PJ9. And you can see there's a little crowding going on here. You can see this wire here is kind of placed in the middle. And I want to add these 4 new wires. It doesn't give us a whole lot of space, okay? So there's a lot of editing tools that are available inside of AutoCAD Electrical. And the one that I'm going to use here is called the scoot command. And the scoot command is basically a conditional move, okay? It's really nice. And what I can do is just select on the wire segment I want to move, and I could simply just scoot it over just like that. So down here too, you know, if I wanted to scoot this one over a little bit, you can see even though it's got that wire loop in there and it's actual multiple wire segments, it's very easy to slide over. And maybe I've even decided that, wow, this splice really isn't a good location. I'm just going to grab that, going to scoot that over too. And you can see very easily I can adjust and move things around. And the scoot is that conditional move. So that component, like the splice, is only going to slide on the wire. And it's only going to let me slide it to the extent of that wire or to maybe where another component is. It's not going to let me move it past it. So it's a conditional move command, basically. Okay, so now I've got enough space in here. And I'm going to go ahead and connect PJ6 to PJ9 up there. And, you know, using the wire command, I could certainly do that. But do I want to create 4 independent wires? That would probably take quite the process, you know, or at least, you know, some extra work. And I'm all about making things quick. So this is where you could use the multiple wire bus command. And inside of this command, it allows us to place multiple wires at a time. These wires can be connected to another bus. They can be dropped in empty space. Or in our example, we're going to connect these to existing components, okay? So existing components is good. Gonna select OK. A little hard to see because my background color is white, but basically it's put these little green X's everywhere, and those are all the potential points I can connect to. And I'm simply gonna draw a window around those 4 pinpoints. You can see they then turn red. Those are the 4 that I want to do in this case. So I'll just hit enter. There's no more to add. And once I hit enter, now I'm creating that multiple wire bus. Okay, I can move my cursor around. Now these act a little bit differently than a single wire because they are a little bit more complicated. You'll see here they're not going to automatically turn for me. However, there's a bunch of commands that you could use, and whenever there's extra options, you always need to make sure you check the command line. So in this case, I could continue or flip these. So the first thing I want to do is flip them because I don't want to change the order. So if I type in F, then enter, you can see now it's kind of flipped them. So now the wires aren't crossing anymore. And now what I'll do is kind of get it positioned where I wanted. So he's kind of like in the middle here between the connector and that other wire to the right. And then I use the C enter command, which then allow me to turn it the other direction. Now watch what happens to the wire spacing here too. As I go to the connector, you can see it's automatically going to space because I use that component connection option. So just like the connector can adjust to the wires in the multiple wire bus command can also adjust to the connector wherever you've placed those pins, especially if you've manually placed those pins and maybe they're not exactly 3/4 of an inch apart. Okay. So I have all the wiring done at this point. This looks pretty good. I like it. The circuit is done. But what about those pesky wire numbers? Now, if you've used AutoCAD in the past, you know placing wire numbers was painful, let's face it, because essentially you're putting in manual text entities for each one of those wires. Now, inside of AutoCAD Electrical, we have project properties number 1, and these are for determining the wire numbers. So %N basically just stands for number, okay? And that number is going to conform to a standard. Now that standard can be a PLC IO address. It could be a line reference, so it could be at XY, X zone location, or a ladder reference number, which clearly we don't have in point-to-point wiring. So in this case, we're going to use the sequential numbering. So basically starting at 1, and then every wire it goes to, it goes up indexes by an increment of 1, because that is the default. To apply wire numbers to this drawing, and I just want to point out, I think some were already applied to this project, but when I go to wire numbers, what we're going to do is say we're going to start this at number 10 in this case. And if you already wire numbered some of your project, maybe you want to make sure that you don't wire this or try to apply wire numbers to the same wire twice or things like that. What I'm going to do is actually use a pick option, okay, pick individual wires. And this is nice if you want to be very selective in what you're doing. In this case, we really care about the cable, the end result. And the cable we care about is in between these two connectors. So it's this connector, that connector. And we want to make sure all these things have some proper wire numbers. Maybe the wires on the other side of this connector too, so we could see some connection information. So I'll just highlight the ones I want to wire number in this case. I'm going to hit enter. And then AutoCAD Electrical is going to go to work, and it's going to apply all those wire numbers for us automatically. Now, once we get those in there, we may want to make a few adjustments. You can see how it's applied these wire numbers. Maybe they're not exactly where we want. So we have a lot of different commands in here. One of those is move wire number, and I simply just pick a new place on the same wire where I want to move it to. You know, maybe I want to move this one down there. We also have some options just for sliding these around. Oops. We could use the scoot command, so I can scoot, say, number 19 over a little bit, like so. So we have move wire number, which you just pick the wire any place, and it'll move the wire number to that place. You can use the scoot command to scoot those wire numbers around. But maybe we also want a nice clean drawing. So this is where we could maybe use an align function. So I can go through, select the master one, pick all the other wire numbers I want to align to it, and simply hit enter. And it's going to bring all those wire numbers into alignment. Okay, once those things are into alignment, I'm now ready to apply my cable information. So we're finally getting to that cable that we want to place. So we've got the connector on either side. We've got all the wire numbers in here. We understand how this thing is designed. Now what I'm going to do is go to the cable command. And there's a number of different cables to pick from in here. I could pick a parent, create a child for one of the conductors. In this case, I'm going to use a shielded cable. And I'm also going to type in F enter, just so you know. And this is going to be a fenced insertion. So it makes it nice and easy. I could just pick one point. Maybe I'll turn on my ortho mode, make sure I'm drawing a nice straight line. And essentially, that is my cable right there. You can see it put X's on all those. I'm going to hit enter. And it's going to open up the edit insert dialog box. Once I have this dialog box open, this is one I'm actually going to apply some catalog data to, okay? So just to show you, I'm going to backspace this, and usually you search for your cable information. I'm just going to search. So you can see there's over 15,000 catalog items for cables in the database, okay? And what you do is use the different search criteria to go out and find your specific cable. Now in this case, I know the cable catalog number, which is an 8445. So you could search by catalog number, you could search by description, type, gauge, miscellaneous information. There's a ton of different fields in here you could use to search. And what that is going to do is reduce your record count so you could find the one that you need. Or maybe it doesn't really matter and you could pick from a list. Maybe if you search for a multi-conductor cable that's 22 gauge for conductor, you know, maybe there's only 20 results, and then you could just pick one from the list. So I'm going to go ahead and assign that, click OK, and click OK, and now it has some catalog data associated with it. I'm going to go ahead and just save this now. All right, so that was the schematic side of it. So we went through, we created wires and connectors and wire types, and finally that cable. And now what we want to do is bring it all together as a layout. Okay, so we want all that cable information in a layout. And that layout is going to be basically using footprints that we've seen, that we've created, and we can understand those, and building basically this bi-directional link between the schematic and that layout environment. So the layout environment can be anything. It could be as simple as that connector, or it could be that power supply, it could be an enclosure, it can be a push button, whatever it happens to be, you could build in these bi-directional links. Okay. Beyond that, as long as you're entering and connecting things together, you know, catalog information, you're connecting the wires to one connector to another, all that information is going to be captured and can be reported back to you. Okay, and there's several different ways to report that information. So let's go ahead and take a look at this. I'm going to go ahead and just switch my drawing here. Okay, so here we go. What I want to point out is the connectors already have been connected together with that link, okay? And the process is the same, so I didn't want to go through it like 4 times, okay? And if I just right click on this and edit footprint, you can see basically it's got that same tag, PJ11 on one side, PJ6 on the other. That's the connection between those two connectors. Okay, those are those two connectors essentially. Okay, so let me show you how to build this link, and it's actually a pretty simple process. So this here represents our splice. Let me do this one first. So I'm just going to go ahead and edit this footprint, and up here it says component tag. And if you keyed in a value here, it's not linked to anything, okay? And that's where a lot of people make the mistake here in trying to build this relationship. You don't want to enter a tag here. What you want to do is go look at your schematic, and I do this by using the schematic list. And if I look through here, splice 3, SP3, that is the splice that was on the other page. So I'm going to click OK, and basically that's how I can build that link. You can see how simple it is. I'm going to click OK. Now that's linked to that splice on the other page. Now let's also do that for the cable. So again, I'll just right click, edit this footprint. I'm going to go to my schematic list, and there it is, CBL1. We only have one cable that we created. It's called CBL1. I'm going to click OK. Notice as soon as I do that, it's bringing across the catalog information. So keep in mind, you know, by not typing it in, that is a quantity of 1 for this cable in this project, not 2, because that's the same cable. It's got the same tag. We've linked them together. And to even prove that out, if I click OK here, what I can do is use the surfing command, the surf command. So right over here, surfer. And what it's going to do is take a look at that component. And it's basically showing me here, P basically stands for parent, pound is the footprint, and all these ones in between are the conductors, the individual conductors of that cable, because this is a parent, these are all children. So I'm going to select on that parent component and do a go to, so it's going to go to wherever that reference is, and it's going to take me to that other page, and it's going to zoom me in right into that cable because I've built that link between these two components, and essentially they're just a single component with references on 2 different pages, okay? And it's literally just that simple. And of course, if I want to go back, you go down here to this bottom one, the footprint, go to, and it's going to take me right back to where that reference is. And I know that these components are linked together. And the software is smart enough because there's some of that intelligent error checking and things like that. If I were to delete one of those, okay, just delete it straight up, the software is going to ask me if I want to surf to anywhere where that was referenced. So it's really nice. So it guarantees that you know that you should go clean up maybe some other pages in your drawing when you delete something out of one sheet. Well, it maybe need to be deleted in multiple sheets. Okay. Now the next thing that we're going to take a look at here is the pin information. So we've got these connectors. You can see we have several references. So it's actually connected. This PJ6 is actually referenced in 3 different locations. You have the schematic. You have up here that's showing kind of how the cable is connected together. So this is the cable, these are the connectors, this is where the splice is. But beyond that, it's also connected to this down here. And why would you want to do something like that? And it's because you want to know what pin goes to what wire, right? You want to know exactly how this cable is wired, not only just the simple representation of the cable, but how is it wired? And it's going to make that guy in the shop, his job really easy, right? Because he's going to see exactly how to do this. And we have the ability to show wire annotation, okay? And I'm just going to do this for the couple of components that I want to pick on. And we could show multiple different attributes in here, wire numbers, wire layers, wire tags. There's all this different information, okay? And I'm going to show it as the wire number, so the tag and terminal, okay? So wire number and tag. So that wire number I just added on the other sheet, it knows what pin it's connected to on that connector, and that's the information that I want to display here, okay? You can also do wire layer and things like that too if you want to know the specific wire too. So you literally could have wire layer, terminal number, and wire number, and it's all the information that you need. You even know what wire to pull off the shelf now. I'm going to go ahead and click OK. Simply going to pick the 2 connectors that I want to do. Going to hit enter now, and you'll notice what we have. So we have different pin information. We have different connector information. So over here, pin 1, wire 14, pin 2, wire 15. And And of course, you could include the wire gauge and information like that if you wanted to as well. Now, the other thing is, maybe we also want to provide a report, okay? And there's several different reporting capabilities that we have in the software here. I'm going to use a schematic report, and specifically, we're curious about the cable from to, okay? And we're going to actually do this for the whole project because, well, at this point, only one cable exists for our project, and that's what this report is going to show us. Going to select OK. We'll go ahead and save this. Make sure we check all the drawings for cable information. This screen here, when I talk to customers and training and things like that, location codes are so important. In this case, we don't have any location codes in there right now, but it's something I highly suggest in training. Location codes are super important. It allows us to have more capabilities and flexibility in telling us exactly what's in the report. In this case, it's basically just doing everything. But if we only wanted to run a report, what's the cable that runs from the machine cabinet number 5 to the junction box or something like that. You could actually have it show reports like that. And here is our report. So you can see there's basically cable 1, and then we have different pins. So here's our, I don't know why we have the same pin numbers in there, but pin numbers, wire numbers, and then our second component, our second pin numbers. Oh, here's our pin numbers. Component 1, component 2, here's our pin numbers. This is our wire number PLC. That's something different. So maybe something like that isn't necessary. So I could actually go in, find that. Let's get rid of that column. We don't want that information. Let's save it. Oh, let's just click OK there. There we go. So now we got our cable information, our wire information, component 1, our pins on component 1, component 2, our pins on component 2. So now we have everything in this report that we need, not any extra information we don't need. They might be confusing. So I'm going to go ahead and place this onto the drawing. Of course, when you place something onto the drawing, there's lots of different options in here for the styles of the table, to the rows, to the location. You can also export this to a file if necessary. In this case, I'm going to go ahead and just drop it straight in, and we'll close out. And now I've got that report right in my layout document. So people, they can see information several different ways here. You could see what components and pins at the component symbol itself, or you could simply see that information in a report. So there's several different ways to show the same information. And the key is really, building intelligent electrical symbols, making sure you're putting in things like catalog information, and it really ties everything together. So one thing I wanted to make sure I did in closing here is talk about some of the top reasons to move from like AutoCAD to AutoCAD Electrical, okay? And a lot of people out there are still using just plain AutoCAD to do simple documentation like that. And really, it takes a lot more effort to do that same level of work in standard AutoCAD than electrical, because you have that specialized tool set that's built for you. And because it includes things like the library, the automatic wire numbering, the ability to do real-time error checking and build out reports, understand cross-referencing between components, coils, contacts, or even just connector to connector, multiple references of the same component in there. Smart panel layouts, that connection, if one thing changes, you need to update that other thing, okay? And don't forget all those electrical specific tools, the scoot command, very handy, just slide things around from one place to the other. Multiple wire bus, creating multiple wires at the same time and connecting those different things together. Wire types, so you have an understanding of all those things. And there's a lot of other functionality that we didn't have time to cover today, and certainly we could have a more in-depth conversation if you want to reach out to me. We can talk about these things, okay? Lots of different tools. So at this point, I'm going to go ahead and see if there's any questions in the queue. I believe you could also raise your hand if you have a question. So if anybody has a question at this time, you can raise your hand. Just digging through. Doesn't look like there's any questions in the queue. Let me check the chat. Did anybody type anything in the chat? Nothing's in the chat. Again, if there's any questions, you could also raise your hand. Let me see here. It doesn't look like anybody's raising your hand. So I'll give you just one moment. If there's any type of questions that you'd like answered regarding what I've shown today, go ahead and cue that into the questions area or the chat area, or you could simply raise your hand and I can unmute your line if you wish to ask a question live. All right, so I don't see anything coming in. So I guess I'm going to assume I did a great job telling you guys everything you need to know, but realistically, I know there's probably some questions out there. So if you do have something at all, you can email me at tshaul@m2t.com. So TSHAUL at m2t.com. Or you could call in. That's certainly an option too. Here's the phone number. We also have a sales support that will put you in contact with a salesperson. You can also check out our website. We have all of our training outlines up there. So if electrical training is one of those things that you're going to think you need, especially after seeing this and you want to take a stab at that point-to-point stuff and want to get in, we certainly offer training on all these areas. So with that said, I'd just like to say thank you for joining us today for today's webinar on point-to-point schematic wiring using AutoCAD Electrical, specifically for cables. So thank you very much and have a nice day.